China just launched a new generation of self-driving cars that are shocking the entire world. Right now, over 1 million autonomous vehicles are operating on Chinese roads, completing more than 600,000 driverless rides every single day across 200 cities. That's more autonomous vehicles than the rest of the world combined, by a factor of 10. While American companies test dozens of robotaxis in controlled zones, China has entire fleets operating without safety drivers in rush hour traffic, typhoons, and conditions that would shut down every Waymo in San Francisco. Companies you've never heard of are running profitable autonomous taxi services cheaper than Uber. Automakers are selling fully self-driving cars for $30,000, and buses are navigating entire cities without a human being behind the wheel. And this isn't some future vision. This is happening right now, today. The most advanced system currently deployed comes from a company that's already operating on 3 continents. WeRide's Robotaxi and RoboBus unified platform. You're looking at the only autonomous driving system on Earth that can control a taxi, a bus, a delivery van, and a street sweeper using the exact same artificial intelligence. WeRide launched this unified platform in 2024, and it's already operating 500 vehicles across 12 cities in China and the Middle East. What makes this shocking isn't just that one company built autonomous technology for multiple vehicle types. It's that they solved the hardest problem in self-driving, making a single brain smart enough to handle completely different machines in completely different situations. A robotaxi weaving through downtown Guangzhou traffic, a 40-foot bus picking up passengers at precise stops, a delivery van navigating narrow alleyways, all controlled by identical neural networks that learned from over 1 billion kilometers of real-world driving data. The sensor technology behind WeRide's system makes everything you've seen from Western companies look primitive. Solid-state LiDAR with 0 moving parts scans the environment in 3 dimensions out to 500 meters, that's over 1,600 feet, far enough to see around curves and over hills before human eyes could process what's coming. 4-dimensional radar tracks objects through smoke, fog, and total darkness by measuring not just position but velocity in real time. 28 cameras capture every angle simultaneously, while the AI processes all of it, every single frame, at 1,200 trillion operations per second. And here's what should terrify Tesla and Waymo. This computing power uses less electricity than your laptop, while processing over a terabyte of data every single hour. But the real breakthrough is how the AI actually thinks. Traditional autonomous systems need to be trained separately for each vehicle type, spending years learning how a car handles versus how a bus turns. WeRide cracked transfer learning, where knowledge gained controlling one vehicle instantly applies to another. The system learned smooth acceleration in taxis, then immediately applied that understanding to 40-passenger buses. It mastered tight parking with vans, then used that spatial reasoning for precise bus stop docking. You're watching artificial intelligence that gets smarter with every vehicle type it controls, and it's already operating commercially in Guangzhou, Beijing, Singapore, and Abu Dhabi. Passengers are booking rides through an app, climbing into vehicles with empty driver seats, and arriving at their destinations with timing accurate to within 60 seconds. The rides are profitable without subsidies. The comfort exceeds luxury sedans, and WeRide is the first Chinese autonomous company approved for international operation. But WeRide's global expansion is being overshadowed by a deployment so massive, it's rewriting what's possible with autonomous vehicles. Baidu Apollo Go's 5th-generation platform. You're watching the largest autonomous vehicle fleet on planet Earth complete 40,000 driverless rides every single day in the city of Wuhan alone. Baidu Apollo Go operates over 300 robotaxis in Wuhan, with expansion fleets in Beijing, Shenzhen, Chongqing, and 6 other major Chinese cities. While Waymo celebrates operating a few dozen vehicles in Phoenix and San Francisco, Baidu is running what amounts to an autonomous transportation network at city scale. Passengers pay $2 per ride, less than a third of what an Uber costs, and the vehicles operate 24 hours a day without breaks, without sick days, without the limitations of human drivers. This isn't a pilot program. This is a functioning business that's already completing over 10 million autonomous rides per year. The technology making this possible comes down to one brutal achievement. Baidu cut the cost of LiDAR to $1,500 per unit. For context, when Waymo started testing autonomous vehicles, a single LiDAR sensor cost $75,000. Baidu didn't just improve the technology, they obliterated the economics that kept self-driving cars trapped as rich company experiments. Their fifth-generation system uses proprietary LiDAR units manufactured in Chinese factories at scale, combined with 48 cameras that process every angle simultaneously. The neural networks running this fleet were trained on 30 billion kilometers of simulated driving. That's enough to circle the Earth 750,000 times, exposing the AI to every scenario, from pedestrians jumping into traffic to motorcycles cutting between lanes. But here's where it gets devastating for American competitors. Apollo Go vehicles don't just see the road in front of them. They're connected through 5G networks to 4,000 smart intersections across Wuhan that feed real-time data directly into each vehicle's navigation system. Your robotaxi knows a bus is approaching an intersection 2 blocks away before that bus is even visible. It knows traffic light timing for the next 5 intersections. It receives warnings about construction zones, accidents, and hazards before human drivers would see the first orange cone. The AI evaluates 2,000 possible driving paths every single second, constantly recalculating the optimal route while identifying 300 different object types, from construction barriers to plastic bags blowing across the street. And the system has achieved 99.99% uptime, meaning it's more reliable than human drivers and smoother in operation than luxury cars with professional chauffeurs. Baidu's plan isn't to dominate 10 cities. It's to expand to 100 cities by 2027, creating an autonomous transportation network across China that will complete hundreds of millions of rides annually. Yet while Baidu revolutionizes robotaxis, Chinese automakers are doing something even more audacious, putting this technology directly into cars you can buy and drive home today. Xpeng's XNGP City Navigation Pilot System. You can walk into an Xpeng dealership right now and drive away in a car that navigates entire cities autonomously without any pre-mapped routes. The Xpeng G9 and P7 come equipped with XNGP City Navigation Pilot, a system that operates in 243 Chinese cities it has never seen before, on roads that have never been digitally mapped, in conditions that would leave a Tesla waiting for a software update. This is full autonomous city driving, available to consumers today for $35,000, less than the price of a base model Tesla Model Y. And the most shocking part? The system just works. You set a destination anywhere in the city. The car takes over, and it handles lane changes, roundabouts, construction detours, and parking lots without a single human input. The technology making this possible is built around dual NVIDIA Orin X chips pumping out 508 trillion operations per second of computing power. 2 forward-facing LiDAR units scan the road ahead, while 11 cameras and 12 ultrasonic sensors create a complete picture of everything around the vehicle. But here's what separates Xpeng from every Western autonomous system. It doesn't need high-definition maps. Traditional self-driving cars require teams of engineers to pre-map every road with centimeter-level accuracy before the vehicle can operate. Xpeng's AI generates navigation paths in real time by understanding road rules, traffic patterns, and spatial relationships the same way a human driver would in an unfamiliar city. The car encounters a temporary detour around construction. It plots a new route instantly. The parking lot has been repaved with different lines. The AI adapts and parks anyway. And the system is learning from over 1 million Xpeng vehicles on the road right now. Every time any Xpeng navigates a tricky intersection, merges onto a highway, or handles an unexpected obstacle, that data flows back through over-the-air updates to improve every other vehicle in the fleet. The AI has already mastered 92% of city driving scenarios without any human intervention. Lane changes happen smoothly. Overtaking slower vehicles is confident and precise. Roundabouts are navigated with better spatial awareness than most human drivers demonstrate. The car even handles the chaos of Chinese traffic, motorcycles weaving between lanes, pedestrians jaywalking, delivery trucks double parked. And if the system encounters something it cannot handle, driver monitoring cameras track your attention, giving you up to 3 minutes of hands-free operation on highways before requiring you to take over. This is autonomous driving technology that costs less than a mid-range American sedan, operates in hundreds of cities without special infrastructure, and improves itself continuously through fleet learning. But Xpeng isn't alone in bringing military-grade autonomous technology to everyday consumers. NIO's NAD Full Autonomous Driving System. You're looking at a luxury electric sedan that drives itself better than most professional chauffeurs, and you can access the full autonomous capability for $67 per month. NIO's NAD system, short for NIO Autonomous Driving, comes hardware-ready in every ET7, ES7, and ET5 that rolls off the production line. The Aquila Super Sensing System packs 33 sensors into each vehicle, one LiDAR unit with 500-meter range, that's over 1,600 feet of forward vision, 11 8-megapixel cameras capturing detail human eyes would miss, and 4 NVIDIA Orin chips delivering 1,016 trillion operations per second of processing power. This is more computing horsepower than the servers running most small businesses, installed in a car you can buy today starting at $60,000. What makes NIO's approach revolutionary is the subscription model that turns autonomous driving into a service you can turn on and off like Netflix. Pay $10 monthly for basic features or $67 for full autonomy, and the capabilities unlock through over-the-air updates without ever visiting a service center. Navigate on Pilot Plus handles, complete highway driving, executing lane changes when faster vehicles approach from behind, managing highway ramps and merges, maintaining safe following distances that adjust based on traffic flow. The urban autonomous features operate in 46 Chinese cities right now, recognizing traffic lights, stopping for stop signs, yielding at crosswalks, navigating complex intersections that would confuse lesser systems. Every scenario encountered by any NIO vehicle anywhere in China feeds back into the cloud, training the neural networks that control every other vehicle in the fleet. But NIO engineered something no other automaker has achieved: autonomous battery swapping. Their power swap stations across China allow the vehicle to approach the station, align itself with millimeter precision, and complete a full battery exchange in 3 minutes without the driver touching a single control. The car navigates into the swap bay. Robotic arms remove the depleted battery, install a fresh one, and the vehicle drives away with a full charge, faster than you could fill a gas tank. NIO has completed over 8 million autonomous kilometers without a single major incident. The system has driven through typhoons in Guangzhou, snowstorms in Beijing, and desert heat in western China that reaches 120 degrees Fahrenheit. And this technology that rivals anything Waymo or Cruise developed is available right now to Chinese consumers as a monthly subscription in vehicles priced for the premium market, not as vaporware promised 5 years from now. Then came the announcement that changed everything about autonomous vehicle accessibility: BYD's DePilot Autonomous System. You're watching the moment autonomous driving became affordable for ordinary people. BYD, the company that sold over 3 million electric vehicles last year and dethroned Tesla as the world's largest EV maker, integrated full autonomous capability into cars starting at $23,000. The DePilot system comes standard in the BYD, Han, Tang, and Seal models, vehicles priced lower than a Honda Accord, but packed with technology that most luxury cars cannot match. And here's what should terrify every Western automaker: 300,000 BYD vehicles with DePilot are already on the road today, making this the most widely deployed autonomous system from any car manufacturer on Earth. BYD achieved this by cracking the cost problem that has plagued autonomous driving since the beginning. Instead of expensive LiDAR arrays that add tens of thousands of dollars to vehicle price, DePilot uses a camera-based system with 12 ultrasonic radars, 5mm wave radars, and 12 high-resolution cameras processing the world through pure computer vision. The computing platform comes from Huawei's MDC system, delivering 300 trillion operations per second, and the entire package adds just $2,000 to the vehicle cost. But the real genius is the data advantage. BYD sold over 6 million vehicles globally, and every single one feeds real-world driving information back into the neural networks training DePilot. The AI has learned from more actual road kilometers than any Western system has even simulated. Navigate on autopilot handles, complete highway driving, managing everything from lane keeping to navigating construction zones, where lanes shift and merge unexpectedly. Traffic Jam Assist takes over in stop-and-go congestion, the most mentally exhausting driving scenario for humans, maintaining safe distances and smooth acceleration that actually improves traffic flow. The automatic parking feature handles spaces so tight that most drivers would give up and find another spot, maneuvering with centimeter precision into gaps that look impossible. And memory parking learns your regular routes to home and work, then completes those exact drives autonomously once the pattern is established. The car remembers which lane you prefer, where you usually park, even which entrance you use at your apartment complex. But here's the achievement that matters most. BYD made autonomous driving accessible to average Chinese consumers earning average incomes. Not tech executives, not early adopters with money to burn, but regular families buying practical transportation. A nurse in Shenzhen, a teacher in Chengdu, an engineer in Wuhan can all afford vehicles with autonomous capability that rivals systems costing 3 times as much. While premium brands competed for wealthy buyers, BYD was quietly democratizing technology that American companies are still reserving for $100,000 luxury vehicles. Yet even as consumer vehicles revolutionized personal transportation, China was deploying autonomous technology at a scale that makes individual car sales look insignificant. Shenzhen's autonomous bus network. You're watching 50 12-meter buses, each the length of 2 full-size pickup trucks, navigate the densest city traffic on Earth without a single human being behind the wheel. Shenzhen launched the world's first fully autonomous bus routes in 2024. And these aren't empty test runs on closed courses at 3 in the morning. These are actual public transit buses, carrying 60,000 passengers every single week through the Futian district, operating on dedicated lanes that weave through construction zones, merge with regular traffic, and handle the organized chaos that defines Chinese urban transportation. 0 safety drivers. 0 backup operators. Just artificial intelligence managing 40 passenger loads through 40 kilometers of city streets while maintaining schedules accurate to within 30 seconds across 20 different stops. The sensor suite mounted on each bus makes autonomous cars look under-equipped. 16 LiDAR arrays provide complete 360-degree coverage, scanning every angle simultaneously to track pedestrians, stepping off curbs, motorcycles, cutting between lanes, and delivery trucks blocking intersections. The AI doesn't just navigate the route, it manages every aspect of bus operation that human drivers handle. Passenger safety monitoring through interior cameras, door operation timed to platform alignment, emergency protocol responses if someone pulls the stop cord or if the system detects a medical situation. And here's the technical achievement that sounds impossible until you see it happen. These buses dock at stops with precision within 2 centimeters, less than an inch of variance, positioning perfectly for wheelchair ramps and elderly passenger boarding every single time. But the real power comes from integration with Shenzhen's smart city infrastructure. Every traffic signal along the route communicates directly with approaching buses, adjusting timing to maintain schedule flow. Smart stops send passenger count and wheelchair accessibility needs before the bus even arrives, allowing the AI to adjust speed and docking procedures. The system knows if construction blocked a lane 3 intersections ahead because road sensors transmit real-time hazard data that gets processed faster than any human dispatcher could communicate it. When an emergency vehicle approaches from behind, the bus doesn't just hear a siren. It receives digital notification of the exact vehicle position and optimal pullover location, then executes the maneuver with smoother precision than panicked human drivers swerving to the shoulder. These buses handle merging traffic at speeds up to 50 miles per hour, navigate construction detours that weren't part of any original route planning, and yield to emergency vehicles with reaction times measured in milliseconds instead of seconds. The AI has been trained on every possible scenario, from children chasing balls into the street to elderly passengers who need extra time boarding. And Shenzhen isn't stopping at 3 routes. The city plans to convert its entire bus fleet to autonomous operation within 5 years, creating a public transportation network serving millions of daily riders without human drivers. This is municipal-scale autonomous deployment that makes Western robotaxi experiments look like hobby projects. And China is exporting this exact technology to cities across Southeast Asia and the Middle East. But while government infrastructure grabbed headlines, another company was quietly proving autonomous vehicles could operate profitably in conditions that would shut down every Waymo in California. Pony.ai's Dragon Capsule System. You're watching robotaxis. Operate in Beijing winters, where temperatures drop to -20 degrees Fahrenheit. In Guangzhou typhoons, with rain so heavy it overwhelms windshield wipers. In Shenzhen traffic so dense that motorcycles weave between cars with inches of clearance. Pony.ai's Dragon Capsule System has been running 250 vehicles across these 3 cities since 2023, completing 70,000 autonomous rides every single month in conditions that would paralyze Western systems. The sensor fusion technology combines LiDAR point clouds with camera vision in real time, creating a 3-dimensional understanding of the environment that works when cameras are blinded by rain and when LiDAR struggles with snow. 4 independent computing systems provide quadruple redundancy, meaning 3 systems can fail completely and the vehicle still operates safely. The neural networks process 3 gigabytes of sensor data every single second, making thousands of micro decisions about speed, positioning, and path planning faster than human reflexes could respond. And the AI doesn't just react to what it sees, it predicts what will happen next. Pedestrian movement forecasting calculates where someone will be 3 seconds from now based on their body language, walking speed, and head position. The system knows a delivery driver is about to step into traffic before the door even opens because it recognizes the vehicle type, stopping pattern, and door handle movement. Vehicle-to-infrastructure communication through 5G networks gives each Pony robotaxi abilities that seem like science fiction. The car reads traffic light timing for upcoming intersections, receives hazard warnings from road sensors before visual confirmation, and coordinates with other autonomous vehicles to optimize traffic flow. When you watch a Pony.ai vehicle navigate rush hour in Guangzhou, you're watching artificial intelligence operating with information density and processing speed that human drivers cannot match. And this technology has been operational for over 2 years, refined through millions of real-world kilometers in the harshest conditions China can deliver. Yet even this proven system looks conservative compared to what launched 3 years ago and still outperforms most Western autonomous vehicles being tested today.